All right, what's up, everybody? The other day, there were some individuals who made a response to me. 7 hour and 11 minute hangout in response to a 6 minute video I put up the other day. I figured we'll play a certain section that had to do with dissolving, because I think that it's very relevant to origin of life and those types of topics that we bring up a lot. For the most part, I mean, obviously, I didn't watch this whole Hangouts because it was very, very long. But from what I did see from it, there wasn't really much else to really hit on, anyways. It was mainly this mantra of, um, you know, we're too stupid to understand things, or we're too ignorant. That a lot of atheists present here online or talk about here online. And we know that mantra. It's not important. But this is. So let me screen share this little section of this Hangout so that we can get a good idea of what's been said here. All right. Hopefully that should be screen shared. I can't see if you guys can see it from here, but I'm going to play it anyways. So hopefully you guys can hear it. Make sure I turn up the volume really quick. Actually, give me 1 second, guys. All right.
And the grain of sugar is going to break up like we saw the grain of salt break up, but it's going to break up in a different way. It's going to break up into the individual molecules that made it up. But these molecules are not going to break up.
You need to select the window. I don't think you selected the right window.
And those molecules are going to start floating around in the water.
I'm on the right window.
Oh, sorry. Why are we not seeing you then?
I just see you. I don't see the video. I can hear it just fine.
Hold on. Right, here we go.
Yeah, you weren't presenting, were you? Yeah.
Look, that's it. Right, here we go. I'll run it back ever so slightly, okay?
There we go.
Right, ready?
Pay very close attention to what this guy says.
Why don't you pull it?
But these molecules are not going to break up into the individual atoms. They're going to stay as molecules, and those molecules are going to start floating around in the water. A big mistake that people make, I don't want you to make this mistake, is they think that when sugar or other covalent compounds dissolve, they think that the atoms that make up the molecules totally break apart. And then you end up with a glass of water that has all these carbon and oxygen and hydrogen atoms just floating around. That does not happen. Big red X. Instead, the molecules stay together. Well, the atoms in the molecules stay together. So this is a big difference between how covalent compounds dissolve, where the molecules stay molecules, and how ionic compounds dissolve, where the grains of things like salt actually break apart into the individual atoms. So, to answer the question, what does it look like when moves in water? The short answer is, it actually really depends whether you're talking about an ionic compound or a covalent compound. If it's an ionic compound, it's going to break apart into all of the individual atoms. But if it's a covalent compound, the clump of the molecules will break apart into individual molecules once it dissolves. But the molecules themselves will not break apart into atoms. They will stay as molecules, dissolve in the water.
Listen to how
And
they
there you
react.
have it.
And DNA is a covalent molecule. It stays together. There we go.
Yeah.
That's
It couldn't be any better, could it?
discussion over. It's done. We win. Ronnie's full of crap. I mean, I don't know where to even go with this anymore. I mean, this
This is actually the video that he claims proves me wrong.
Oh, is that? I've never seen it. Is that? I
That's
heard about
The irony of it.
Yeah, I didn't. I knew you had it. I knew that video existed. I heard you talking about it. I never bothered to watch it. But I think you screen cap. I think I've seen a screen cap from it before somewhere down the line.
So there you have it. This is the video that he claims that I used that proves me completely wrong.
How does he even get to that? How does he get that? How does that prove you wrong? What is his reasoning on that?
I think he mistook when the guy said it breaks apart. Even though the guy went on to qualify to say the molecules remained intact, he used the word break apart at one point, describing the covalent molecules. And I think he sort of focused on that, even though the guy specifically several times said, emphasized it, that the individual molecules remain intact. And I think he used the words remain intact. And yet,
Yes.
Oh,
This is a video he was whinging about, saying I hadn't showed the whole video.
Wow.
Now, the beginning part of the video that I've not shown was what the ionic compound does. It breaks into the individual ions. Okay? But
all right. Take this off really quick. All right, so I guess to better get an understanding of what was really said, what my claim is, and why this video is actually very beneficial to me. I think we need to understand that my claim is, and it's been from the beginning, that DNA, if not utilized within a relatively short amount of time, is going to start to break down or to start to degrading. But specifically what my claim was that DNA, when it dissolves, when it breaks down or comes apart, is going to stay deoxyribose nucleic acid. It's going to stay DNA, but it's not going to be in sequences anymore. Now, obviously, it would be very silly for somebody to use that video as a response to refute that claim if then they're going to try to compare DNA with that type of covalent bond like sugar. And remember, Fiona's the one who shared that video. Fiona's the one who gave me that video in a response to supposedly try to prove me wrong in some sort of way. So here's the point. My claim being that DNA is going to stay DNA and it's going to break down into its sequences. Sugar is going to stay sugar, but it's going to break down. As you heard it said word for word. How did those individuals respond to what I said or respond to my claim? They ignored the fact that it said broken down. They gave it a little bit of a mention really quick, but they sort of pushed that away. They tried to zero in on when they said, well, it's going to stay sugar. But obviously, that's not what my claim is. And you can tell in the tone of Steve McRae, for example, he knew after he watched that clip, when Fiona screen shared it, that my claim was just proven word for word. If you're going to compare sugar to deoxyribose nucleic acid DNA, my claim that I made was 100% confirmed and correct right there. But I don't want to really leave it right here. I would like for us to actually get involved with what it actually means to dissolve, because I think this is really, really important, especially for people that are going to be listening that don't really know about the technical details of chemistry. I think this is really important because this relates to abiogenesis in early Earth. So let's take a listen to what of what it means to dissolve, dissolution, the process, and so on. Let's take a really close listen, because remember what the Fiona's claim is. And remember what these other individuals' claims are, that DNA or anything that is meant to dissolve, not just the solubility of DNA, but when something dissolves, all that's happening is that it's going into solution. Obviously, it's going into solution, but that doesn't answer the question. The question is that what happens in a chemical level when something goes into solution. So let's get into that right now. I'm going to try to screen share this one more time. I guess I'll do the entire screen. I do not know if you guys can see the screen that I'm sharing. I'm just assuming you can. Sometimes when I'm doing this through G+, it doesn't want to work. But try to screen share this. Hopefully that you guys can see this. This video has to do with dissolution and solubility. Well, you know what we should do? First of all, we should ask, is DNA soluble in water? Here's something right here really quick so that you guys can have quick access to read. It says DNA is polar due to its high charge phosphate backbone. And what they're talking about is that partial negative charge at the phosphate backbone. It says its polarity makes it water soluble. Water is polar according to the principle of dissolves like. But what does it mean for something to dissolve? Let's take a listen to that. So remember, DNA is able to dissolve. What does that mean?
Look at an example we're all familiar. Hi, I'm Robin Higgins, and this is What Does Dissolve Mean in Chemistry? So, when we talk about something dissolving, what we mean is that it has separated from itself.
It has separated from itself. Pay very close attention to that.
And is completely in solution. So let's look at an example we're all familiar.
So when it goes into solution, whatever is soluble has separated from itself.
With of salt or sodium chloride. So at first, if you put salt into water, little waves here, it acts as a solid still. It completely falls to the bottom and just kind of hangs out, right? And over time, if we stir it or if we heat it, it dissolves and you can't see it anymore. And so what's actually happening in terms of chemistry when that happens? Well, salt is formed of ionic bonds, and in water it separates into positively charged sodium atoms and negatively charged chlorine atoms.
So they are separating or they are breaking apart.
The reason it dissolves is because it actually interacts with water. So I'll draw a little waters here, and of course the waters are H2O, and you have little bonds. So in water, the oxygen atom is actually partial negative, and the hydrogens are partial positive. And the positive sodium is attracted to the partial positive, the oxygen, and it actually forms little intermolecular forces, and these keep the salt completely dissolved. So the reason that salt dissolves in water is because there are intermolecular forces in between the positively charged and negatively charged ions of salt and the dipoles of oxygen. And so the reverse is true with the chlorine. So chlorine is full negative, and it's attracted to the partial positive of hydrogen. And so the attraction between these guys is strong enough to separate the sodium and the chlorine. So let's look at an example of something that does not dissolve. So this is a little cube of iron, Fe. It's just hanging out. And if you looked at it, you would see that all the iron atoms are bonded to each other. So if you leave that cube of iron in water, or you stir it, or you heat it, you're still going to have that cube of water. It doesn't dissolve, right? And that's because the intermolecular forces within iron are too strong, and they're not interested in bonding with water, so it doesn't dissolve. I'm Robin Higgins, and this has...
Okay, guys, so we're looking into what it means to be soluble right now. DNA is water soluble. We understand what it means for something to be soluble when it's dissolving. This is the point of this video right here. It's separating. It's causing the molecule to come apart. And obviously, and we'll get into that a little bit later. And I believe the first video, I'm gonna try to screen share the first video that they were screen sharing, so that you guys can get a better idea of what happens with ionic and covalent compounds. But I think we should get a little bit more detail into what it means to dissolve or what solubility means. Let's get into the situation of dissolution.
Hi,
I'm doing this, guys, because whenever I explain this, it seems like it goes on deaf ears. So hopefully people will pay very close attention, because when I tell you that something is dissolving, it means that it's coming apart, breaking apart, or degrading. This isn't up for debate right here. These terms are synonymous with each other, and this is fact. This is what happens on a molecular level when something is dissolving. So pay very close attention.
Robin Higgins, and this is, are dissolution and solubility related? Yes, definitely. They're very similar. Okay, so a couple of definitions. Dissolution is the process of a solute dissolving in a solvent becoming a solution. And solubility is whether or not a solute can dissolve. So basically, dissolution is just...
Okay, so we understand that DNA is something that can dissolve because it's soluble. So pay very close attention and see, because I'm leading this somewhere, and I hope that you guys are going to follow this and pay very close attention to the terms that are being used right now.
Fancy science word for dissolve, and solubility is whether or not something will dissolve. So I'll explain with an example. So here, let's pretend we're making some Kool-Aid. So at this first cup, we've just added our powder here. It's sitting on the bottom. We've got our water all around it. Now, after time or stirring, we basically make our Kool-Aid. So it's just all turned pink, and there's no longer any particles in it. If you looked at a certain part of it over here and then looked at it over here, it would look exactly the same. There's no difference. And this is what dissolving really is. It's that it's completely homogeneous, which means it's the same all the way throughout. So just to kind of think about another example, if we took a rock from the ground and put it in a cup of water, it doesn't matter how much we stirred it, right? It would just be a rock in a cup of water. It would not dissolve. It is not soluble. So let's take a look at some factors that can increase solubility. Well, there's the nature of both the solute, the solid, and the solvent, usually the liquid. So if you have things that are very similar, so for instance, sugar is kind of polar and water is very polar, they'll dissolve, then they will probably be soluble and it probably will have good dissolution. If you have things that are very different, like a rock and waters, there's some metal versus water, they're not similar, they're not going to dissolve. A rock.
So we understand what the process of dissolution is, okay? Let's get a more detailed description of what is actually happening right here with dissolution. Dissolution is the process, and I hope you guys can see what I'm screen sharing, you guys. Dissolution is the process through which a solute forms a solution and a solvent. The solutes, and of course we just got a pretty good description just now from this lady. The solute is the case of solids, has its crystalline structure disintegrated as separate ions, atoms, and molecules form. Well, what did that just say right there? The solute, in the case of solids, has its crystalline structure disintegrated as separate ions. What does disintegrated mean? Disintegrated means something that breaks up into small parts. Something that breaks up into small parts. Now, we know that this is exactly what happens right now when something is soluble. The process that undergoes something that is soluble, it breaks up into parts. Already now, from the very first video that the first individual showed that they were playing stupid on, it confirmed exactly what I was saying word for word. That DNA, for example, what I've been saying from the beginning, DNA will stay DNA, but will break down into specific sequences. They compared that with the covalence compound of sugar, staying sugar, but breaking down. And they pretty much ignored where it said break down and only paid attention to the fact that it said that it was going to stay sugar. Remember that DNA, like as I said, that it has to be in specific sequences. It will no longer be in specific sequences after it's broken down. So we're here already. We already know that by now what I'm saying has already been confirmed. But she still says that what is soluble, something that's able to degrade or something that's able to break down, is not equivalent to something degrading. But we already know something, it's break up into small pieces. Let's take a listen or look at what it means for something to be able to degrade, okay? Break down or to deteriorate chemically. To break down or to deteriorate chemically. Now, I mean, even her own source actually that she showed, let me take myself off screen share, I guess, for a moment. Even her own source that she showed, I hope you guys can't hear that in the background. I got my dogs here making a bunch of noise. But even the video that she shared at the beginning that had to do with you know, it was a process of bringing the DNA through an aqueous solution. I don't remember exactly how it went, but there was one part of this process that she did not read, and I screen shared it the other day, where it talked about DNA must be kept at, I believe, negative 20 degrees Celsius, and it must be stored at this temperature because it would, if it's eluted with water, because it will degrade. Literally, it said that word for word, it will degrade. We have to keep in mind that these processes that we're talking about, everything that I led you through, is what soluble means. I led you through it. DNA is water soluble. What does soluble mean? What does it mean then when something is dissolved? What is the process of dissolution? And everything means that it's going to disintegrate, break down into smaller pieces, and that's what it means. And this is synonymous with saying that it is to degrade. Now, she brought in something the other day talking about an hydrolysis reaction. We need to pay very careful attention to this, because something that can undergo an hydrolysis reaction may or may not be water soluble. The bonds that, for example, she was pointing to were not the soluble parts of DNA. The soluble part of DNA is that partial negative charge on that sugar phosphate backbone. That's what makes it soluble. Those intermolecular bonds that she was pointing to between the guanines, the thymines, cytosines, and adenines, those were not the parts of the strand that made it water soluble. But what she was pointing to was, was really just mainly an hydrolysis reaction that was interacting with that. That was mainly dealing with cleaving, anyways, to begin with. It wasn't dealing with what was going to happen when something dissolves. But I'd like for you guys to watch the first video that she screen shared, because I think that before we move forward, I think that it would be better for us to get a full understanding of what was said. I think that her video that she shared, she did it really sloppily. So I'm going to try to screen share this so that we can get a better picture. Entire screen. Give me 1 second, guys. All right, so let's see here. What happens when things dissolve?
What happens when stuff dissolves? I mean, like, what happens to the atoms and molecules that make it up? I want to talk about two things here that you dissolve all the time.
Keep in mind, remember this. You got to remember every single thing we're talking about. If something is water soluble, that means it's easy to dissolve in water. Now, they're explaining what happens on a chemical level when something dissolves. The response has always been that it goes into solution. Fiona is not giving us an answer when she makes that statement. Nobody's giving us an answer when they say it goes into solution. We know it goes into solution. The question here is at what happens on a molecular level. So I want you to pay attention to the terminology being used, what's being said, how he's describing it, and compare that with every other definition that I've given you, because every single definition that I've been giving you is consistent all the way across the board. Pay very close attention.
Salt and sugar. These two things look very similar. They're both like kind of white powders made up of little grains, and you could pour both of them into water and stir around. And you see the grains get smaller and smaller, maybe break apart, until eventually they've totally disappeared. They've completely dissolved in the water. That's what you see with the naked eye. But if you had atomic vision and you could see the atoms that make up salt and sugar, what would it look like as these grains broke apart and became invisible? That's what we're going to talk about here. So it actually depends whether something is an ionic or a covalent compound. It depends on what it would look like when it dissolves. So over here we have salt, and this is an ionic compound. This is what a grain of salt would look like, and it's made of sodium ions, Na+, which are metals, and Cl, chloride ions, these blue things here, which are nonmetals. So salt is an ionic compound made of metals and nonmetals. Sugar, on the other hand, is a covalent compound because it's made of nonmetals, carbon, oxygen, and hydrogen. And these nonmetal atoms are connected together into a molecule. So a grain of sugar would look like this. It would be a bunch of these sugar molecules all kind of lumped together. Notice that a grain of sugar is a lot more messy. It's not nearly as well organized as an ionic compound, this grain of salt over here. Anyway, let's look at what would happen when we dissolve these. We'll take a grain of salt, dip it in the water, and start stirring around. With our atomic vision, we're going to see that the atoms that make up this salt are going to come apart from each other. They're going to break apart, and they're all going to start.
They're going to break apart. They're going to come apart.
Floating around in the water individually. This is what it looks like when salt dissolves. Okay. Now let's take our sugar. Here's our grain of sugar. It goes in the water, we stir it around, and the grain of sugar is going to break up like we saw the grain of salt break up, but it's going to break up in a different way. It's going to break up into the individual molecules that made it up. But these molecules are not going to break.
Did you hear what he said? It's going to break up. Well, he just explained it perfectly right there. It's going to break up. It's not going to break up the same way that an ionic compound will break up.
Up into the individual atoms. They're going to stay as molecules, and those molecules are going to start floating around.
Now, you heard what he said, that sugar is going to break up into individual molecules, but it's going to break up and it's going to stay the sugar molecule. It's going to say sugar.
Water. A big mistake that people make, I don't want you to make this mistake, is they think that when sugar or other covalent compounds dissolve, they think that the atoms that make up the molecules totally break apart. And then you end up with a glass of water that has all these carbon and oxygen and hydrogen atoms just floating around. That does not happen. Big red X. Instead, the molecules stay together. Well, the atoms in the molecules stay together. So this is a big difference between how covalent compounds dissolve, where the molecules stay molecules, and how ionic compounds dissolve, where the grains of these things like salt actually break apart into the individual atoms. So, to answer the question, what does it look like when something dissolves in water? The short answer is, it actually really depends whether you're talking about an ionic compound or a covalent compound. If it's an ionic compound, it's going to break apart into all of the individual atoms.
So you see the terminology being used. It's going to break apart. Factually, it's going to break apart. It's going to start separating. It's going to come apart. That's what's going to end up happening. This is what is meant by something that is dissolving. Remember, she says that it's not the same thing as something that degrades, but the definition of degrade is what? Something that breaks down or deteriorates chemically. Now, again, all of the descriptions that I've given you are synonymous with each other. They are consistent all the way across the board. Take my screen share off. This is not up for debate. I mean, when something breaks down, when something is water soluble, when something dissolves in water, that means it's going to break down, or it's going to start to separate amongst itself, or any other synonymous description with that. It's going to break down, and this is not up for debate here. I want to also make this statement as well, because this is really important. It also depends on what is involved in the water as well. That doesn't mean that's going to keep it from dissolving. What I mean by that is the concentration of water, things like that. Because depending on the state that's within inside of the water, for example, and I've mentioned this a couple times, bringing up the Chatelier's principle and so on, but all of these different, I don't know how to put it, intermediates or fluctuation states or whatever within inside of the water, or the concentration of water, the amounts of water, or if you have too much salts, too much sugar inside of the water, look at it like something like that, too much salts or too much sugar inside of the water, and it doesn't reach equilibrium with the water, it might fall to the bottom of the glass, and that's an experiment that everybody else can go check out. So if it doesn't reach the equilibrium with the glass, then you might have that sugar or salt fall at the bottom of the glass as well. So if you have, too much sugar, or being the fact that DNA is supposed to be a weak acid. All of those things you have to take into consideration as well, to see, well, how long will it take for this to dissolve? Now, it's not going to take millions of years for this to happen like she's talking about. She's talking about something that is, again, a hydrolysis reaction. That's not the same thing here. We're talking about that sugar phosphate backbone and that partial negative charge, which is going to cause it to break down. And that is not equivalent. I'm not referring to the phosphodiester bond. What she's talking about when she's talking about the phosphodiester bond was what I mentioned in Hogtie's Hangout. Now, I made a mistake when I said that. When I talked about the phosphodiester bond breaking up, me and Hogtie were speaking from off the top of my head. It wasn't like, well, this is what it is. What I said was that, are you referring to the phosphodiester bond? Because we were both just speaking from the top of our head. But even the phosphodiester bond, these other bonds as well, none of those things that are breaking up in there, like she was talking about, are breaking up because they're water soluble. And the environment in which she's claiming that they would happen, in the heat or whatever, or whether or not they would be able to survive as long. They're very unrealistic, especially considering where this topic is coming from. I was talking about the early Earth scenario. Early Earth scenario, again, comes down to about 1800 degrees Celsius to about 200 degrees Celsius, 100 degrees Celsius. And 1800 degrees Celsius, what was that, 2,800 degrees Fahrenheit? 100 degrees Celsius, I'm not convinced that anything's going to last that long, obviously. I mean, when she was mentioning it at 30 degrees Celsius or about 25 degrees Celsius, that would have allowed it to last 31 million years, just that bond. Remember, again, it wouldn't have been in sequences, but this segment would have been able to last maybe 31 million years. But you have to also take into consideration the fact that the early Earth environment would have probably made that break apart probably within maybe a couple of hours to a couple of days. And all the other bonds would have probably disintegrated much, much earlier than that, probably within only a few minutes of time. Even if we're going to grant that and I don't believe this at all, that the early Earth would have cooled down quick enough for the bonds to survive. Even if we're going to grant that, the fact still isn't going to get them away from that sugar phosphate backbone, which is going to cause it to degrade and to come apart, like we just explained right here. It'll no longer be in sequences and it'll be useless. Now, you got to keep this in mind as well. None of these people believe that DNA was the first self-replicating molecule for life. They believe that maybe it was an RNA or some sort of pre-RNA as well. And you got to keep it in your mind that RNA is far more fragile than DNA is. I'm not even sure how quick that would dissolve within itself. So I think that I've proven my points perfectly clear here. I guess I'll check the comment section and see what's being said. Myself to bed. Tired. What time is it? It's 5 in the morning. Man, you guys are so stubborn. I mean, how do you get any more clear than this? The separate DNA strands break apart, but the DNA stays whole. The separate DNA strand breaks, but the DNA stays whole. No, it doesn't. It breaks down. It's going to break down to its constituent parts. I don't know why you're thinking that it's just going to stay in two separate complementary strands. Where are you getting that from? It says DNA doesn't break because it's a molecule like the sugar. You're making the mistake he said not to make. No, he said, well, you can go replay it. I'm going to put the link in the description so that you guys can watch it. He said it's going to stay a sugar molecule, but it's going to break down. I'll put it right here so that you can watch it in the comment section. Make sure I put it in the comment section or the description as well, because I'm going to take myself to bed as soon as I'm finished with this. What are you talking about, rational mind? To keep digging the hole, Roddy. I've only listened to a couple of minutes, and I've already heard you repeat the same mistakes yet again. All right, I just showed multiple different definitions or descriptions of what it means to be soluble. I walked you all the way down from what soluble means to the description of dissolution, disintegrate. Every single description so far has literally been synonymous with the exact same wording that I've used. So what exactly is it that I'm getting incorrect here? Okay, what do you mean? Yes, Ronnie, that's the video that you keep misunderstanding. What video? All of them are saying the same thing. I mean, come on. We cannot like keep playing this game. I mean, if I'm saying that DNA is going to stay DNA, but it's going to break down to its constituent parts, and you guys keep on saying, well, that doesn't mean it's going to degrade. It doesn't mean it's going to break down. All it means is it's going to go into solution, and the descriptions all the way across the board are saying it's going to break down. It's going to disintegrate, which means it's going to break down. Degrade means, chemically speaking, that it's going to deteriorate or break down chemically. Well, then what is the problem here? I mean, because like really, literally, word for word, all the way across the board, I'm 100% right. There's not the slightest implications in any way at all that I'm wrong. It says DNA is a molecule, Ronnie. Do molecules break down? The video said molecules don't break down. No, the video said that it is going to break down. I'll replay it so that you guys can watch it. I don't know how you guys are missing this, but I will replay it right now. You tell me what it is that I'm missing from what I'm seeing, all right? I'll replay it. Give me 1 second here. All right.
Very similar. They're both like what kind of white powders made up of little grains, and you could pour both of them into water and stir around, and you see the grains get smaller and smaller, maybe break apart, until eventually they've totally disappeared. They've completely dissolved in the water. That's what you see with the naked eye. But if you had atomic vision and you could see the atoms that make up salt and sugar, what would it look like as these grains broke apart and became invisible? That's what we're going to talk about here.
Broke apart.
So it actually depends whether something is an ionic or a covalent compound. It depends on what it would look like when it dissolves. So over here we have salt, and this is an ionic compound. This is what a grain of salt would look like, and it's made of sodium ions, Na+, which are metals, and Cl, chloride ions, these blue things here, which are nonmetals. So salt is an ionic compound made of metals and nonmetals. Sugar, on the other hand, is a covalent compound because it's made of nonmetals, carbon, oxygen, and hydrogen. And these nonmetal atoms are connected together into a molecule. So a grain of sugar would look like this. It would be a bunch of these sugar molecules all kind of lumped together. Notice that a grain of sugar is a lot more messy. It's not nearly as well organized as an ionic compound, this grain of salt over here. Anyway, let's look at what would happen when we dissolve these. We'll take a grain of salt, dip it in the water, and start stirring around. With our atomic vision, we're going to see that the atoms that make up this salt are going to come apart from each other. They're going to break apart, and they're all going to start floating around in the water individually. This is what it looks like when salt dissolves. Okay? Now let's take our sugar. Here's our grain of sugar. It goes in the water, we stir it around, and the grain of sugar is going to break up like we saw the grain of salt break up, but it's going to break up in a different way. it's going to break up into the individual molecules that made it up. But these molecules are not going to break up into the individual atoms. They're going to stay as molecules, and those molecules are going to start floating around in the water. A big mistake that people make, I don't want you to make this mistake, is they think that when sugar or other covalent compounds dissolve, they think that the atoms that make up the molecules totally break apart. And then you end up with a glass of water that has all these carbon and oxygen and hydrogen atoms just floating around. That does not happen. Big red X. Instead, the molecules stay together. Well, the atoms in the molecules stay together. So this is a big difference between how covalent compounds dissolve, where the molecules stay molecules, and how ionic compounds dissolve, where the grains of these things like salt actually break apart.
Okay. So again, guys, dissolution means that it's going to disintegrate. Structure is going to disintegrate. Disintegrate means it's going to break up into small pieces. Remember, they said that degrade doesn't mean the same thing. Let's go back and check out what degrade means. Degrade definition. Degrade means it's going to break down or to deteriorate chemically. Yep. What's the problem, guys? Let's see what you guys are saying now. Yes, Fiona, the molecules stay molecules, but the molecules are breaking apart, obviously, right? So remember, you can't ignore that. You can't just say, well, hey, they're staying molecules. You're doing just what I was pointing out inside of the video. They're going to stay molecules, but they're going to break down. So you're looking at DNA, it's going to still be deoxyribonucleic acid. It's going to still be DNA, but it's going to be broken down as well. It's not going to be in sequences anymore. Yes, DNA is a molecule. That's kind of the point. That's the reason why I think Fiona was comparing it to covalent compounds, the sugar molecules. Yes, he said specifically that molecules stay molecules. That's the point. It's going to stay molecules. DNA is going to stay a molecule, but it's not going to be in sequences anymore. Is it important for DNA to be in sequences or not? Where are you getting it from? If they're going to break into separate strands, I mean, where are you getting that from? I don't think I'm going to get an answer, am I? Rational mind says that the separate DNA strand break apart in the same way that an individual people in a crowd break apart. No, that's not what happens at all. Where's the sugar phosphate backbone at? Where are those charges located at between, these different points? Where are they found? We got to look at where they're going to be broken down. I mean, there's nothing indicating they're going to split right down the middle when you're going to have these two complementary strands. There's nothing at all indicating that. So go look at the atoms and the sugar molecule in the video and then compare the solid picky to the dissolved picky. Compare the solid picky to the dissolved picky. The problem is that the charges, the charges, they're not located running straight down the middle. So I don't know what you're talking about. Where are you getting it from that it's going to break into two complementary strands at? Okay, well, first of all, I'm ignoring one point right here because I'm so tired. I guess we're now backtracking, right, Fiona, one more time. Now you're saying that it's going to break down the middle. So we're acknowledging that it's breaking apart now, right? It's breaking apart now, right? Are we acknowledging that it breaks apart now? I said all I can say, guys. I might do another hangout like this tomorrow night, maybe, or tonight. I gotta get myself to bed. I think I proved my point perfectly. DNA does break down. Remember, Fiona disagreed that that degrade is synonymous, or it means the same thing as dissolving. I walked you through what that means. We'll deal with whatever new backpedaling information they're going to be presenting next. But I'm right. I think you guys just need to acknowledge that already.